In this problem, we're placing a hot piece of lead in some cooler water. If we contain all that heat into the lead and the water, what is the final temperature? And so if these come to the same final temperature, then the heat lost by the lead is equal to the heat gained by the water itself. And so the mass of one object times its specific heat times its original temperature plus the mass of the second object times its specific heat times its original temperature divided by the mass and the specific heat of that first object plus the mass times the specific heat of the second object. And again, this comes from saying the heat gained must equal the heat being lost, having to rearrange that, solve for the final temperature. And so this final temperature, let's say our lead is object number 1, our water is object number 2. So the mass of this lead, okay, notice we're given grams for the lead and for the water, but our specific heat's given to us as kilograms. So for this lead, 0.056 kilograms, took 56 divided by 1,000, times its specific heat, 0.11 kilocalories per kilogram degree Celsius, times its initial temperature of 100 degrees Celsius, plus the values for the water, 260 grams, so 0.26 kilograms times 1 kilocalorie per kilogram degree Celsius times its initial temperature of 11 degrees divided by those same values without using the temperatures in the denominator. All right. Sorry, my handwriting's getting a little sloppy there. Kilograms are going to cancel. Kilocalories per kilogram degree Celsius cancel as well. We're left over with Celsius. All right, so 0.056 times 0.11 times 100 plus 0.26 times 1, okay, times 11. All right, so we have our numerator. Now we're going to divide that by 0.056 times 0.11 plus the 0.26 times 1. And so we get a final temperature of 13.1 degrees Celsius.